In the previous two sessions, we saw how to find the resultant using graphical method. Now this graphical method will be much simpler if there are only two forces acting upon a body. Say this is a body and there are two concurrent forces acting. If there are more number of forces, still we can use the graphical method, but it becomes very tedious and cumbersome to use. It is for that reason we are introducing a new method which is called the analytical method. This method can be used for any number of concurrent forces, not just two. So here afterwards it will be much simpler if we try to understand this analytical method. Before finding out the resultant of many forces, first of all we have to understand resolution of a force into its components. Now in parallelogram law we studied that if these two forces can be represented by the two sides of a parallelogram, okay, and this is one force, say F1, and this is another force, F2, and the diagonal of this parallelogram will give us the resultant force in magnitude and in direction. Now what are we actually doing? There are two forces and as if we are combining them to a single force. Now resolution means it is the inverse of this parallelogram law. Given a force say R, then we can divide it or decompose it into two forces which we call as the components. Now parallelogram law, what we do, we combine two forces, given two forces, and then find out a single force which we call as the resultant. Now assume there is only a single force now which we call as R. Now this force can be decomposed. This is the inverse of parallelogram law. This can be decomposed into two forces. How do we do that? Initially we have to define axis like this. Now let these two be the given axis. I want to resolve this force into components along OA and OB. Now how do we do that? Draw a line parallel to this axis and draw another line parallel to this axis. Now wherever these two lines, this line is parallel to this line is parallel to this, wherever it meets, that will define the components of the force. This is the component of R along OA, and this will define the component of R along OB. Now we have chosen these axes OA and OB just as a representation. Now we can also use any other axis. Now what do we mean by that? Suppose I choose some other axis, a set of axes, say this is OA and OB is like this, and I want to resolve this force, given force, into components along the two given axes OA and OB. All we have to do is draw a line parallel to this and draw a line parallel to this. Now wherever they are going to meet, that will define the components R, OA, and this will be R, OB. So in parallelogram law, we combine two forces to arrive at the resultant, whereas in the resolution, given a force, we resolve them into two components along the two given axes. Now, this method of dividing a given force into its components is called resolution of the force into its components, and these ones along the axis are called the components of the force. Now, as I told you excuse. Now, as I told you, the axis can be in any direction, but we will be interested only in one set of axes in which both these axes are perpendicular to each other. So, given a force, here we called it as R, right? Here afterwards we'll use the force as F. Now I want to resolve this force into components along two perpendicular axes, and generally we call these axes as the x-axis and this will be y-axis. And in some textbooks you may even notice that this, they call it as a horizontal axis and this as the vertical axis. Now we have to find the components of the given force along these two orthogonal or perpendicular axes. What you have to do, draw a line parallel to this. Wherever it meets, that will give me the x component of the force. It is also called horizontal component. Some people call this as x component and some people call this as horizontal component. Now in the same manner, to obtain the component along y-axis or vertical axis, draw a line parallel to x-axis, and wherever it is going to meet, okay, that will define the y component of the given force. Now some textbooks, they even call this as vertical component. So a given force can be resolved into components along two perpendicular axes, which are nothing but x and y axis. The corresponding components, we call them as fx and fy. And since they are resolved along orthogonal direction, these components are also called orthogonal compounds. Orthogonal components or rectangular components. Now, given a force, how to arrive at these components? Now you know this is a rectangle and opposite sides will be equal. If this is Fy, this is also Fy. Now let's say the given force of magnitude F is inclined at an angle, say theta, to x-axis. This is x-axis, it is inclined at an angle of theta to x-axis. Then if you try recollect what you studied in max, then side opposite to the angle will be sine. So this will be F sine theta and this will be F cos theta. So we can find out the resultants of the given force along x and y axis or horizontal axis and vertical axis as follows. Fx is equal to F cos theta. Now some textbooks, they call this as, instead of Fx, they call this as F horizontal component along horizontal axis, and the vertical component, which is Fy, as I told you, some textbooks call this as Fv, which is equal to F sine theta. So given a force and an inclination angle theta, we can find out the components of that force along the two orthogonal axes, namely x-axis and y-axis, as this. Now, how to choose axis x and y? It is very simpler in this case. Let's consider another case where we have to consider the representation of these x and y axis. Now the choice of x and y axis is as per our convenience. For instance, let's say a block is resting on an inclined plane and a force, say the weight of this block W. Sometimes we will have to resolve this force. Let's say the inclination of the inclined plane is theta. We have to resolve this force along the axis parallel to this plane and perpendicular to this plane. In such cases, we can choose the axis as per our convenience. It will not be always horizontal and always vertical. So it is better to call these axes as x and y. Right now we can fix the axis, x-axis parallel to the plane and y-axis perpendicular to the plane. Now how to find the components or the x and y components of this force? All we have to do is draw a line parallel to this. These are the x and y axis. Now from this tip you draw a line parallel to this, and from here draw a line parallel to this line. Now wherever this force is going to meet, that will give us the x and y components of this force W. This becomes the x component or the component parallel to the plane, and this gives us the component perpendicular to the plane. And if you will notice that, let's say I am extending this triangle, then this becomes 90 degrees. If this is theta, this has to be what? It will be 90 minus theta, because this is 90 degree. These two have to add up to 90 degrees. Now these two lines are crossing each other. So this angle will be same as this angle, 90 minus theta. And here it is 90 degree, and this angle will happen to be theta. So whenever you have an inclined plane, if the inclination angle is theta, then this perpendicular to the plane will make an angle theta with the vertical line. Blindly you can write this. Instead of going into all these trigonometry, you can directly write, if a block is given which is resting on an inclined plane of theta and this is the weight, then this angle will always be theta. Blindly you can follow this.